Now let's go ahead and move forward here to the next problem. So in this example, same thing. We will start by reading the question sentence. Everybody, what are we trying to look for? What are we trying to obtain here at the end of this situation? What do we want at the end here? What is it that we want? Yeah, I see the word total for sure. That's definitely something we'll want to highlight. Yeah, now we got to add a little more context to it, right? We need a little more story with that because total could mean a bunch of different things, a bunch of different ways. But when we say we need how many pounds and ounces of flour in total, that makes a lot more sense. We want to know at the end the grand total of pounds and ounces. Okay, boom. Now that we know what we're trying to end up at, let's begin understanding what we have to work with. The way I like to think about it is, what do we want? The question. What do we have? The information. And what's the connection? Translating that English into math. So here we go. What we have here is a recipe calls for 2 pounds, 5 ounces of flour. Okay, let me highlight that right there. We have 2 pounds and 5 ounces for the recipe. And then what we need to do here says, if we need to make 3 batches of this recipe for a large party, how many pounds and ounces of flour will you have in total? Okay, cool. So let's understand this a little better because there's a couple of different ways we can do this, but there's a very simple way that we can go about this. Everybody, if we have 2 pounds, 5 ounces, how many batches are we trying to make? Yeah, we're trying to make 3 here. So pretty much what's going on here is we have this 3 times over. That is 3 batches. And when we add all of this up together, look at how friendly this problem actually is. So everybody, what's 2 plus 2 plus 2? What's that going to be? Yeah, that's going to be 6 pounds. Let's write that down right there. And then 5 plus 5 plus 5, what's that going to be? Yeah, that'll be 15. That'll be 15 ounces. Now, everybody, for the sake of being proper here, do we need to convert these ounces into pounds? Do we have enough ounces to convert into at least a pound? No, we don't. Pop quiz. How many ounces would we need to turn it into a pound? Yeah, we need 16. We're not there yet. We don't have 16. We have less than that. So this is actually already proper. This is already good. 6 pounds, 15 ounces is correctly stated. So we actually don't even need to convert in this problem. It was just a quick little scary for us because I am willing to bet, and y'all let me know in the chat box, and if you're watching this as a recording, just go ahead and just laugh it off to yourself. Who here was instantly nervous about this problem? Before you even knew what you had to do. Before you even knew that you didn't have to convert. See, this is what I'm talking about when I say basic strategy, the fundamentals, starting with the question, then the information, and then trying to understand the connection. When you stick to that basic strategy, my party people, you'll see that there are a lot more questions that you already know how to do. There are so many questions that you know how to do, but the fact of the matter is we just get in our own way. And that's what test anxiety is. That's what test anxiety is. And sorry about that. I highlighted A. It's supposed to be B. Excuse me there, everybody. Appreciate the patience on that. But I hope you all understand that when there's a fundamental strategy involved, you give yourself the best opportunity to stay calm, cool, and collected. Does that make sense before we continue? Sweet. Again, practice, 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 proper practice. All right, let's handle question number 1 under a timer. So the question here, again, the first thing we always want to do is read the question. So the question reads, determine the distance from the park's center to any point along this path. Okay, let me highlight that. Determine the distance from the park center to any point along the path. Everybody, if we were to, draw this out or illustrate this, what are we talking about? If we're trying to talk about this circular park right here, circular park, and we're trying to find the distance from the center to any point along the path. What idea are we talking about, my party people? Yeah, that's the radius all the way. We are looking for the radius all the way. From the center to any point along the path, that is radius. That's the number one thing. Remember, my party people, it's always about, can we identify the goal of the problem? And if it's, contextualized or using words like from the center to any point, well, can we go ahead and interpret that correctly? And in this case, as radius. So now that we know we're looking for radius, look at how that can help us as we move forward. So here, let's read the information. A festival organizer designs a circular park where the entire length of the decorative path, so the entire length of this decorative path measures 28 pi units. Again, the entire length of the path around the park. My party people, what are we talking about there? If we say the entire path is decorated all the way around, if we're decorating the path going all the way around, exactly, we're talking about circumference. So that's how we know that the circumference or the number that they give us here, the 28 pi units, that's how we know that that is circumference. So now that we have this, we're good, because the question we have to ask ourselves now is this. I know I'm looking for the radius of the circle. I know the circumference of the circle. Is there a formula, or what is the formula that connects radius to circumference? What's that formula going to be, my party people? Circumference equals should give us 2 pi r. That's right. That's the formula that connects everything together. Circumference equals 2 pi r. And so what we'll do is we will replace the circumference with its actual value, which is 28 pi right here. And that's going to equal 2 pi r. My party people, are we good from here to get the radius by itself? Can we get the radius by itself from here? Oh yeah, we absolutely can, because we just did our last example was just like this. We know that we can divide both sides by the contents right there. The 2 pi, we can divide that on both sides. And once we do that, the pi's cancel out, the 2's cancel out. On the left side, the pi's cancel out. And the final question is, what's 28 divided by 2? And there we go. The correct answer here will be 14 units. That is the radius of this park. And there we go. The correct answer here will be A. So, first question was a tough one. First one was a tough one where we had to work backwards immediately. But how did we feel about that one? Any comments, questions, suggestions? Go ahead, leave them in the chat box. See if you can get that question in there, a little quickly. But we will move on here shortly to the next one. To answer the questions that I see, do we ever simplify? If we have a fraction as an answer, for sure, we'll always want to simplify with those. If they ever tell us to use 3.14 for pi, then we will plug that in and, clean things up with that. But we just go off of the directions that each individual problem gives us. And Louis, I'm glad that you're starting to see that you can work a little faster when it comes to dealing with circumference, because you know that the pi's are going to cancel out anyway. So you know that 28 is the diameter, cut that in half to get the radius, and you're good. So right on, Louis. And same thing with you, Corey. Same thing with you, Corey. You did the same exact thing. So you're showing that you're starting to get an advanced understanding of this, knowing where you can take some of these shortcuts. Right on. I like seeing that. So with that, let's go ahead and get into the next one here, my party people. Again, under a short timer here. If you're watching this as a recording, feel free to pause the problem and give it a shot on your own. You got this.